You pay $2,000 for a high-end Samsung smart refrigerator. You bring it home and expect it to keep your groceries cold. Then a software update hits, and suddenly that glowing screen in your dark kitchen is pushing mandatory banner ads while you pour your morning coffee. Move to the living room, and the dynamic is identical. Buy a new Vizio television today, and it likely won't complete the setup process unless you link a Walmart account to it. They didn't acquire Vizio for the screens. They bought 20 million living rooms, capturing viewing habits cross-referenced against your household income and grocery patterns. This data extraction extends into the software layer of your web browser. A recent investigation dubbed BrowserGate revealed that LinkedIn used hidden background code to quietly scan visitors' devices for over 6,000 different browser extensions, all without explicit user consent. This is browser fingerprinting. By logging device-level data like memory, screen resolution, and active extensions, the platform gathers thousands of unique data points. When these points are assembled, they reveal highly specific details. Because certain extensions map to your political leanings, health conditions, or religion, the resulting profile is tied directly to your real identity. At the surface layer of our technology stack, the concept of consumer ownership is an illusion. We are paying premium prices to install corporate surveillance endpoints directly into our private lives. As these systems extract our data, the threats targeting them have evolved. Modern cyber attacks don't waste time trying to break down a technical firewall. Instead, they bypass the code entirely and target your courtesy. A major breach of the widely used Axios software library started when an attacker knocked politely, wearing a convincing face. They used an AI-generated deepfake to impersonate a trusted contact and build a relationship with a developer. The intrusion succeeded because the person on the other end was a carefully engineered illusion. Social engineering has become so pervasive that operating systems now have to actively coach human behavior in real time. Apple's latest macOS update includes a feature called ClickFix, which explicitly interrupts and warns users before they paste malicious text commands directly into their own terminal windows. This deliberate exploitation of human behavior extends straight into the corporate algorithms we use every day. Look at the recent courtroom losses for Meta platforms. Prosecutors bypassed debates over user-generated content and successfully penalized the company for its core product design, proving that features were deliberately built to encourage prolonged addictive loops that actively harm minors. The traditional security perimeter is dead. When attackers seamlessly deploy synthetic faces to build trust, and platforms rely on addictive behavioral loops to drive engagement, any defensive strategy built purely on code and technical walls is completely obsolete. If human developers can be routinely tricked by AI, a second question emerges. Can the AI systems themselves be manipulated through the data they ingest? In a recent subliminal learning experiment, a teacher AI communicates with a student AI through abstract numbers. The teacher bakes hidden biases into this harmless-looking data. Even after human researchers filter the data, the student model still absorbs and adopts those exact hidden traits. For the global AI supply chain, this creates a fundamental audit gap. Developers can scrub the data, deploy filters, and ship the model, but they can no longer verify what a neural network has actually learned. They can only observe what it says. The foundations of modern technology are essentially haunted. Hidden agendas, biases, and structural flaws can be permanently baked into an AI's architecture at a level that evades all standard safety checks. Apply that vulnerability to the sheer scale of our expanding digital infrastructure. Driven by AI-assisted coding tools, developers are now generating roughly 1 billion software commits per year on GitHub alone. That massive volume lowers the barrier to entry, but it simultaneously floods the software supply chain. We are rapidly expanding our systems with unprecedented amounts of unreviewed code, increasing the chances of deploying subtle logic errors or those subliminal AI biases. This chart shows the projected timeline for breaking modern RSA encryption using quantum computers. Cryptography was designed under the assumption it would require millions of qubits to crack. But recent breakthroughs in quantum error correction show that the threshold actually shrinks down to just 10,000 qubits, sharply cutting the timeline for when our existing defensive walls expire. This rapidly expanding infrastructure is currently being shaped by a severe geopolitical bottleneck. Right now, the United States controls 98% of Syria's global AI investment. Because of that financial concentration, the AI systems being integrated into critical infrastructure, healthcare, and finance are tethered to a single market. Every frontier model will be shaped by the legal frameworks, incentives, and potential blind spots of one localized ecosystem. The result is a globally scaled system built on hardware that functions as a storefront, human trust that is weaponized by synthetic media, and an AI-driven infrastructure that remains opaque to the very people building it.